Okay, so in a transmission line, the voltage, the signal from the source, we want to transfer it to the load, and we want the load to absorb as much of the voltage as possible. So this is called the incident wave. But some of that voltage gets reflected back. We call this the reflected wave. This reflected wave is bad because it doesn't get absorbed by the load. We want the load to absorb all of the power that we send it. But sometimes it's unavoidable to have a reflected wave. So we measure the incident and reflected wave in terms of the voltage. So the incident wave will be described in terms of V incident and the reflected wave in terms of V reflected. This first one, the gamma or the reflection coefficient, this will be the ratio between the reflected wave divided by the incident wave. It's called the reflection coefficient because in order to find the reflected wave, we only have to multiply the reflection coefficient to the incident wave or the wave that we sent. All right. To find the power reflection coefficient, we only have to square both sides and then divide by some r, because v squared over r, that is power. So actually, the power reflection coefficient is the square of the voltage reflection coefficient. When you say reflection coefficient, it's usually the voltage part. So when we want to find the power being reflected by the load, we have to take into account the square term here. All right. When an incident wave interacts with a reflected wave, something that looks like that, perhaps, when they add together, they will form something called a standing wave, which looks like that. Something like this. And the standing wave amplitude can vary. Sometimes it looks like that, sometimes it looks like the big one, and so on, so on, so on. So it changes every time. Why? Because the incident wave and the reflected wave are moving in opposite directions, so it is changing. And the amplitude of said standing wave may look something like this. Right? This is the magnitude of the amplitude of the standing wave. This, the peak, we call this V max, and the valleys, we call that V min. And the standing wave ratio is actually the ratio between the maximum amplitude of the standing wave divided by the minimum amplitude of the standing wave. Now, when will we find the maximum and the minimum amplitudes? The maximum amplitude, again, the standing wave is a result of the incident wave and the reflected wave. So, we can find the maximum amplitude when both of these are in phase or adding together, right? When we add two things together, for example, like 3 plus 2, we will get 5. But when we subtract them together, we get 1, which is the minimum. So, when we add the incident and the reflected amplitudes, we get the maximum. So, V incident plus V ref for maximum. And for minimum, it's just subtraction, so it's V incident minus V reflected. Alright, let me rewrite the formula on top. You see, the SWR is V incident plus V ref over V incident minus V reflected. We can divide both the numerator and the denominator by V incident. We get 1 minus V reflected over V incident over 1 minus V reflected over V incident. What is V reflected over V incident? That's just gamma. So we have another formula on our hands. Plus here. 1 plus gamma over 1 minus gamma. There. algebraically manipulating this, we can get that gamma is equal to SWR minus 1 over SWR plus 1. From here, we can see the bounds of this. We can see that gamma is between 0 and 1. Vref and V inc. Vref is always less than V inc, right? But Vref is, its minimum is 0, so this can be 0, right? Because you can have a system in which there is no reflected. But for gamma equals 1, that would be having the Vref equal to V inc, which is the worst outcome because there is no power being absorbed at the load, which we don't want. And then SWR is only greater than 1, or greater than or equal to 1. SWR being equal to 1 would mean that the numerator and the denominator here is equal, and that would only appear if Vref is equal to 0, which is what we want, right? And it can go up to infinity. When would that happen? When Vref approaches V inc. The denominator would approach 0, and denominator being 0 would result in it being infinite, or yeah, something like that. So those are the bounds. All right.